Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to look at how to name ketones by looking at their common names, and we're also going to talk about naming ketones using the IUPAC rules. So let's go ahead and start. And so the first thing that we're going to do is we're going to learn how to name ketones using their common names. And so when you guys are using the common names for ketones, it's very similar to that of ethers, where you guys are going to basically treat the left and right side of the carbonyl group as if it was an ether. So here we have an ethyl group, here we have a methyl group. And so once you guys have identified the carbon chain, you guys are just going to organize the name alphabetically. And so notice that E goes before M, so it's going to be ethyl, methyl. And then to communicate to the reader that it's a ketone, you're literally just going to say ketone. And so this naming follows very similar to that of ethers, like methyl ethyl ether. Here in this case, it's ethyl methyl ketone. And so there's specific organic compounds that are widely used that have a specific name to them. It doesn't really follow any rules. It's just out of history. It's born out of history. And so here in this case, if we have a 3-carbon ketone, the name of this would be acetone. If you have a 1, 2, 3-carbon ketone, but one of the R groups is going to be a benzene ring, this is going to be acetophenone. Now, if both of the R groups on the left and right side of this carbonyl group is going to be an aromatic ring, for instance, in this case, a benzene, you're going to say benzophenone. So these common names are just really, really specialized, right? So that's pretty much it for common names. So I'm going to go ahead and go back up a slide real quick. And we are going to learn how to name ketones using the IUPAC method. And so to name an organic compound that contains a ketone, very similar to all of the other naming rules that we've kind of discussed, we're going to find the longest chain that contains the carbonyl group. And we're going to name the parent alkane, or alkene or alkyne, but then we're going to drop the E, very similar to our alcohols or aldehydes. And so instead of putting in an AL or an OL, we're going to put in an ONE. So it's not one, it's own. And so that own comes from the last 3 letters, so to speak, in ketone. And so since ketones are present, since ketones can only be found in the middle, somewhere in the middle of an organic compound, we need to communicate to the reader what carbon number that carbonyl carbon is on. And so if you recall from the previous lecture video, our aldehydes are found on the terminal ends of an organic compound. And so since the carbonyl carbon is on the end of this is at the end of this organic compound, we know that that carbonyl carbon is always going to be carbon number 1. So there's no point for me to put in 1. I'm going to omit that number. However, for ketones, since they're found within the molecule, I can have a ketone in this position, I can have a ketone here, I can have a ketone here, I can have a ketone here, I can have a ketone here. And so since there's many places where ketones are found, then I need to communicate to the reader what carbon number the carbonyl carbon is located, it's at, for me to communicate to the reader that that's where that ketone is. And very similar to aldehydes, thiols, alcohols, we always want to make sure that our functional group, in this case the ketone, gets the lowest carbon number. And so you guys are going to number your carbon chain so that the carbonyl carbon of the ketone gets the lowest carbon number. And then you guys are going to apply all the other rules of nomenclature for substituents, for double bonds, triple bonds, halides, alkyl groups. The list continues. And so we're going to go ahead and go through a couple of examples. And so the example on the left, A, is going to demonstrate how to name a ketone if it is a straight chain. The example for part B on the right is going to demonstrate how to name a ketone if it's in a cyclic ring. So let's go ahead and start with a straight chain. My first step is to figure out my longest carbon chain that contains my ketone. Well, this is my carbonyl group that's the central part of the ketone. And so, therefore, I have to use this carbon because it's connected to my carbonyl carbon, and I have to use this carbon. So all three of these that I highlighted will represent the ketone group. And so for me to find the longest carbon chain that incorporates the ketone, I have to go further to the right. I can't go down, because if I go down, I'll be one carbon short compared to just going across. Now that I've identified my longest carbon chain, I'm going to go ahead and just name my carbon chain. So I have a 5 carbon chain, so that's pent. And since they're all single bonds, that's pentane. Now, according to my rules, I'm going to erase the E and replace it with an one, an O-N-E. So this is pentanone. And so this ketone, the position of the ketone, the position of the carbonyl carbon of the ketone needs to be communicated to the reader. And so therefore we need to go left, right, right, left with respect to the ketone. So here I have 1, 2, 3, 4, 5. And if I go the opposite direction, I have 1, 2, 3, 4, 5. And so since this is my carbonyl carbon, notice that the numbering system in blue, going from left to right, would produce the lowest carbon number for that ketone. And so my numbering system in green is not correct. So I'm going to communicate to the reader that, you know what, my ketone is going to be found, my carbonyl carbon of the ketone is going to be found on carbon number 2. And so after you guys have performed that specific step, you guys just need to describe the carbon number of your substituent, and also describe your substituent. So here I have a methyl on the 3rd carbon, so I'm going to say 3-methyl. So this is going to be 3-methyl. Since I'm going from a letter to a number, I need to put a dash to connect them. And that would be it. So my final answer is 3-methyl-2-pentanone. Okay. All right, so let's go ahead and check out this cyclic ring. And so I can see that my ketone is right here, right? So remember that ketones have the carbonyl group, and then they have the carbonyl carbon is connected by the R group. And so this carbon, these two carbons that I'm dotting, so to speak, that I'm placing dots on, are going to represent the first carbon of that R group. And so very similar to cyclic alcohols and aldehydes, for cyclic ketones, wherever that carbonyl carbon is, that is going to be where carbon number 1 is located. So now that I know where carbon number 1 is located, I have two options. I can number my carbons clockwise, or I can number my carbons counterclockwise. So since my pen is already in blue, I'll just do it counterclockwise first. 1, 2, 3, 4, 5, and 6. And so if I change my color to green to represent clockwise, I have 1, 2, 3, 4, 5, and 6. And so remember that we want the lowest possible number for our substituents. And so here we have two substituents. We have 3 and 5 and 4 and 4. And so since 3 and 4, that's in green, is a lower combination than 5 and 4, then the numbering system in blue is not correct. And so it looks like I have an ethyl that's on carbon 3, and I have a methyl that's on carbon 4. And since I have a 6-carbon cyclic ring, I'm going to go ahead and name my parent chain starting with the word cyclo. And so since it's 6 carbons, it's cyclohex. And since they're all single bonds, since the ring itself is all single bonds, this is going to be cyclohexane. But I can't say ane because I have a ketone. Let me do that in a different color. So here is my ketone. And so I'm going to say cyclohexanone. And in this case, I'm going to omit using carbon. I'm going to omit using that 1 simply because this is a cyclic ring. Wherever that carbonyl carbon is on a cyclic compound, it's automatically assigned as carbon number 1. However, for a ketone that's in a straight chain, wherever that carbonyl carbon is on a straight chain, not a cyclic ring, you have to communicate to the reader what carbon number that carbonyl carbon is on. All right, so now that we have the pieces, we're going to go ahead and just put it together. It looks like I have two different substituents, so I need to list it alphabetically. And so it looks like E comes before M, so I have 3-ethyl. And here I have 4-methyl. And since I'm going from a letter to number, I need to put a dash. And I'm going to go from an L to a C in methyl cyclohexanone. So here, that is going to just be 2 letters that's written consecutively. So there's no dash, no comma, no space. So this would be my final answer. Okay. And so hopefully you guys are getting used to naming these organic compounds. The more practice you guys get, the more you guys have a stronger idea, or you guys can see the pattern just a little bit better. All right, so here in this example, it looks like we have a straight chain. Notice that I have a carbonyl carbon. That's right in the middle of my alkane chain. And so this is going to be a ketone. Okay. So that's going to be my carbonyl carbon. And so we want to make sure that the longest chain contains that carbonyl carbon. So the only way that's possible is if we go straight across. 1, 2, 3, 4, 5, 6, 7. And so it looks like this is a 7 carbon compound. So we're going to write hep. Now if you look at my parent structure, they're all single bonds. So this is going to be heptane. My rule tells me that I'm going to erase the E, add the -one ending, so this is heptanone. And so, unlike aldehydes, I have to tell the reader what carbon number that carbonyl carbon is on. So I need to create a numbering system. So here in this case, I have 1, 2, 3, 4, 5, 6, 7. So this is my numbering system if I go from left to right. If I go right to left, I have 1, 2, 3, 4, 5, 6, 7. And so what I'm going to do is I'm going to look at my first point of difference for the ketone, the carbonyl carbon. And so it looks like they're both the same number. Okay. And so if they're both the same number, then the next, I'm going to go ahead and look at my substituents to see if I have any points of difference. So here I have a 3 and a 5, and here I have a 3 and a 5. So because this molecule is symmetrical, it actually doesn't matter which way you guys number your carbons. It can go left, right, or right, left. Okay. And so I'm just going to go ahead and use my left-right notation, or left-right numbering system. And so it looks like my carbonyl carbon is on carbon 4. So I'm going to say 4. So this 4 answers the question of where the carbonyl carbon of the ketone is located. Next, I need to describe my substituents. And so I have a methyl on the third carbon, so 3-methyl. And I have another methyl on the 5th carbon, so I'm going to say 5-methyl. So when you guys put these two together, you get 3,5 dimethyl. And so since I'm going from a letter to a number, I need to put a dash. Okay. And that would be the name of my compound. All right. So let's go ahead and go through the next example. Same idea, find the longest chain with the ketone. So there's my carbonyl carbon. That's part of my ketone. And so I'm going to go from right to left, 1, 2, 3, then 4, 5, 6, 7. Okay, so if I back step, or if I go back 2 carbons, I have 1, 2, 3, 4, 5, 6, 7. So it looks like in either directions, I'll get 7 carbons as my longest carbon chain. So I'm just going to make it easy for myself, and I'm just going to go ahead and do this straight across. And so once again, I need to figure out my numbering system here. Here I have 1, 2, 3, 4, 5, 6, 7. So if I go in reverse, I have 1, 2, 3, 4, 5, 6, 7. So I'm going to go ahead and take a look at the values that I've written down. So here for my ketone, it's 4 and 4, so that's the same. Very similar to the previous problem. And so if I were to look on the left-hand side, notice I have a 3 and a 5. And if I were to look on the right-hand side, I have a 5 and a 3. And so it looks like all the numbers are the same, but unlike the previous example, the substituents are not the same. So if these substituents are not the same, and you have the same numbering combinations, left, right, right, left, what you want to do is you want to make sure that, so this is like the last resort at this point, you're going to choose a numbering system such that the substituent with a letter that's closest to the beginning of the alphabet is going to have the lowest carbon number. So if you guys can imagine, there's like hierarchy, right? So this, I believe this compound demonstrates it. So the first thing that you want to check is to make sure that your carbonyl carbon for this ketone has the lowest possible carbon number. And in both situations, it'll give us 4 and 4. So that doesn't tell us which numbering system to choose. And so if we look at our substituents then, 3, 5, 5, 3, those are all the same combinations, right? So here I have 3, 4, 5, 3, 4, 5. So that doesn't help us. And so at this point in time, our last resort is to choose a numbering system so that the substituent, the first letter of the name of the substituent, is going to have the lowest carbon number. And so in this case, chloro comes before ethyl. So this is chloro. This is ethyl. It's a 2-carbon compound, so the E comes after C. So the numbering system that we're going to use is going from right to left. Because that'll give us the lowest possible, that's going to give us the lowest possible number for our substituent. All right. So let's go ahead and name this from the very beginning. So C goes first. So here I have 3-chloro. And then the next substituent, ethyl, goes next. So it's going to be 5-ethyl. And then now that we have all of our substituents named and numbered, we're going to go ahead and discuss our parent chain. So since we have a 7-carbon parent chain, we're going to use hept. And so notice that they're all single bonds in the parent chain. So this is going to be heptane. We're going to erase the E, add the -one to describe our ketone. And we're also going to describe that it's on carbon number 4. And so I'm going to go ahead and put a number before the name of the parent to communicate to the reader that, yeah, my ketone, my carbonyl carbon, is on carbon number 4. Okay. All right. So hopefully those two examples give you guys a broader depth of experience when naming these types of complex compounds. All right, so let's go ahead and look at our next example. So here we have a cyclopentane. So no double bonds, all single bonds in the carbon chain. And so I know that I'm going to have to replace the E with the -one. And so since this is a cyclic compound, I know that automatically that this is carbon number 1. And so I'm going to make sure that this carbon number 1 is omitted from the name. And so I'm going to number this such that the lowest carbon number, such that the substituents gets the lowest possible carbon number. And the only way that's possible is if I number it clockwise. So 1, 2, 3, 4, 5. And so here I have a 3-methyl. Maybe I should give some space. So 3-methyl, and since I'm going to omit placing that carbon number 1, I'm just going to go ahead and scoot this guy over so that the L and the C just represents one word. And this is going to be my final answer, 3-methyl cyclopentanone. All right, so let's go ahead and look at our let's look at our next example. I don't think this is our last example. Okay, so this one is it looks a little daunting, right? Because it's a big ring, and there's a whole bunch of substituents. So we need to figure out the correct numbering system: left, right, left, etc., etc., etc. So let's go ahead and start. So first and foremost, we need to count the number of carbons. So that's going to be carbon 1. The carbonyl carbon is going to be carbon number 1. So this is, this is not set in stone when I say 2, 3, or whatever, but I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. So I'm just counting my carbons. So it looks like I have 8 carbons, and it's a cyclic ring. So this has to be a cyclooctane. And so there's a consecutive vowel here. You don't want to merge them. You just have to write it how it's enunciated. So cyclooctane. Okay. All right, so now that we have our parent alkane, we're going to go ahead and erase that E. And since I have a ketone, I'm going to go ahead and put an O-N-E, so cyclooctanone. So now that I know my parent name, I'm just going to go ahead and number it so that I can get the lowest carbon number on my substituents. So I'm going to go ahead and change my color real quick. So let's do this in blue. So if I do this clockwise, I have 1, 2, 3, 4, 5, 6, 7, 8. Do this in green. I'm going to go counterclockwise. 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so really there's only two options because we know that our ketone is going to be carbon number 1. And so for me to figure out which path or which numbering system to use, I have to start comparing the values. Do this in brown. Oops. So first, I'm going to go ahead and look at the bromine. So here I have 3 and 7. And so here I have 4 and 6. And so here I have 3 and 7 as well. And so notice that they're all different. Well, actually, there's 1 point of difference. So let me just go ahead and list it out. So if I were to go counterclockwise, I have a combination of 3, 4, and 7. If I were to number this clockwise, I have a combination of 3, 6, and 7. So the first point of difference, so this is the same, this is the first point of difference. And so notice that the green would produce a smaller value for that substituent than the blue. And so that tells me that my numbering system in blue is not correct. And I'm going to go ahead and number my system counterclockwise. So it looks like I have a 3-chloro, I have a 4-methyl, and then I have a 7-bromo. And so since B comes first before C, and M in methyl comes after, I need to describe the bromine first, the chlorine second, and then the methyl third. And then finally, the parent name of the ketone last. So I'm just going to go ahead and write 7-bromo. And then it looks like I have a 2-chloro, I'm sorry, not 2-chloro, 3-chloro. And then I have a 4-methyl. And that will describe the substituents that's found on this ring. All right, so the last thing that I need to write down is my parent chain. And so I'm going to omit the use of carbon number 1, since this is a cyclic ring. And I'm going to go ahead and just bring this guy in the very front, or I'm sorry, not the very front, the very back. And so my final answer is going to be 7-bromo-3-chloro-4-methyl cyclooctanone. All right. And so hopefully you guys are getting the hang of naming these compounds. I'm going to go ahead and allow you guys to name these organic compounds on your own. I do have the answers somewhere posted in the PowerPoint. So if you guys click on that specific slide and then scroll up, not scroll up, but if you guys look down on the notes for that specific slide and then expand that notes upwards, you guys should be able to see the answers. Um, there are two more problems I want to do, and it's going to be the one with the alkenes, the double bonds. So let's go ahead and check this out. So same thing, same idea. We're going to go ahead and figure out the longest carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. So here I have octane, but I have a double bond in that chain, so it can't be octane. It will have to be octene. And I have a ketone, and so it can't be octene, it has to be octanone. Okay? And so I have to tell the reader or my audience what carbon number does the carbonyl carbon have, and what carbon number does my double bond start on. So there's two things that I need to communicate to my reader. The double bond, the position of the double bond, and the position of the ketone. And so because I have two things to describe, you guys have seen this before, I'm going to go ahead and separate these two, because the number that I'm going to place here represents the carbon number in which the double bond starts. Okay, so this En is once again referring to the double bond. And so after I describe the position, after I describe where the double bond starts, I'm going to have to describe the position where that carbonyl carbon is located in that parent chain. And so this is describing the carbon number of where that carbonyl carbon is found. Same thing here. What carbon number is it? So if you recall, you guys want to number your system to give your ketones the lowest possible carbon number. And the only way that's possible is if you go from right to left. So 1, 2, 3, and then I'm going to erase some of this stuff here. 4, 5, 6, 7, 8. All right, and so it looks like our carbonyl carbon is found on carbon 3, so that answers the question. And if I follow the order in which I've numbered my carbons, it looks like my double bond starts on carbon 4. Okay. Cool. So really the only thing that I haven't described yet is my bromine. So this is going to be 7-bromo. And I'm going to go ahead and add that in front of the name of my parent chain. Sorry, I'm just trying to move stuff over. Gotta save room. Which is silly because I can always move everything over. Anyways. All right, so I have 7-bromo in the front. I'm going to go ahead and add that in. So I have 7-bromo. And since I'm going from a letter to a number, I'm going to make sure that there's a dash right in between. And so this is the name of this specific organic compound. And so we might feel like we're done, right? We're like, yeah, you know, I did it. I named this really crazy looking organic compound. However, we're actually not done yet. Remember in the previous lecture video, I mentioned that whenever you guys have a double bond, you want to check whether or not there's geometric isomerism. And so if I focus on carbon number 4, notice it has 1, 2, 3 bonds. And so there is going to be one invisible hydrogen. So that carbon number 4 has the full octet. If I look at carbon number 5, carbon number 5 has 1, 2, 3 bonds. So for it to fulfill its octet, it needs one more hydrogen. And so if you look at the positions of the hydrogens, well, actually, let me take a step back. First and foremost, on carbon 4 and carbon 5, where that double bond is located, both of those carbons have a hydrogen. So we potentially do have geometric isomerism. And so if I were to cut a plane in half, notice that the hydrogens are on the same side of that plane that I just drew. And so the relationship between these two hydrogens are cis. And so I need to communicate that the double bond needs to be in a cis conformation, such that the hydrogens are going to be on the same side. And so my final answer here is going to be cis-7-bromo-4-octane-3-one. Okay, and that would be my final answer. All right, so let's go ahead and look at the next compound here. So let's see. The first step is to figure out my carbon chain, longest carbon chain, 1, 2, 3, 4, 5, 6, 7. So it looks like I have a heptanone, so I'm kind of skipping steps now. However, I have a double bond, so it can't be heptanone. It has to be heptanone. Okay. So the En is going to represent a double bond, and the One is going to represent my ketone. And so this is the scenario in which you guys have to communicate to the reader the carbon number of where the double bond starts and where the carbonyl carbon is located. So I'm going to go ahead and scoot this guy over. And when I add a number in front of the name, it's describing once again the position of the double bond. And I'm going to separate the N and the ON by adding another number. And this number, this carbon number, is going to describe the position of the ketone. And so recall that for ketones, we want our lowest carbon number to, we want our carbonyl carbon to have our lowest carbon number. So the only way that's possible is to go from right to left. 1, 2, 3, 4, 5, 6, and 7. So it looks like on carbon 3, we have our ketone. And on carbon 5, that is where our double bond is going to start. The only thing that we have yet to describe is our substituent, which is on carbon 6. So this is going to be a 6-methyl. So we're going to go ahead and write 6-methyl. And then since there's nothing else to describe, I'm going to go ahead and bring this closer and connect these substituents with a dash. So this is going to be 6-methyl-5-hep10-3-one. Now, once again, very similar to the previous example, we're not quite done yet because we have a double bond. And so when we have a double bond, we want to see if there is cis-trans isomerism or geometric isomerism. And so on carbon 5, we have 1, 2, 3 bonds. And so for it to have 4 bonds, that fourth bond is going to be a hydrogen. On carbon 6, it looks like it has 1, 2, 3, 4 bonds already. So there are no hydrogens. And since there's only one hydrogen that's on one side of that double bond, then this tells us that there is no cis, no trans isomerism. And so we were correct by just leaving it as is. All right, so that pretty much finishes my introduction of naming ketones. Feel free to practice some more. There's a whole bunch of worksheets posted on Canvas. So the final topic that we're going to discuss in this chapter is going to be reactions of aldehydes and ketones. And so I'll see you guys in the next lecture video. Bye.